Today, our group will present Pratt Truss. Now for the introduction. Truss design can be a confusing and overwhelming subject, especially when it comes to understanding the different types and their unique characteristics. The Pratt Truss is a common and effective truss design that is used in a variety of structures. So, in this report, we'll show what the Pratt Truss is and its static system, which member act in compression or tension, and calculate the internal force. For the background of case study, the Pratt Truss, patented in 1844 by American engineers Salad and Thomas Pratt, played a crucial role in 19th century industrialization, especially in bridge construction. Its distinctive diagonal and vertical members provided exceptional strength and stability, making it a preferred choice for iconic structures like the Brooklyn Bridge and Quebec Bridge. This design adapted to the contemporary standard, showcasing efficient load distribution through tension and compression elements. This study explores specific Pratt Truss application, delving into engineering challenge, innovative solution, and lasting impact on the built environment, offering insight into its historical, structural, and functional significance.
Good morning to everyone. My name is Noortina Maisara, and I would like to present about and telling you more about literature review and engineering application. Okay, for the literature review, we have in this Pratt Truss, we have two members, which is vertical members in compression, and the diagonal member are in tension. Okay, this member can carry loads with relatively long span compared to beams. Usually this bridge carrying a traffic like a traffic jam or something. So this bridge can manage to carry heavy loads like that. And this characteristic by its diagonal member are inclined with the same angle. Okay. This pattern of diagonal and vertical truss member leads to the load that the loads are evenly distributed across the truss. Okay, based on the Theodore, he managed to not even design it because the structural case study, because the structural efficiency are intrinsically non-redundant. They incorporate elements whose localized failure would precipitate collapse. Okay, which means maybe the bridge would be collapsed, so he could not manage to design it very well as it should. So for the there are also long span bridge formed. They are susceptible to progressive collapse due to the loss of a series of adjacent members as a result of a single loading event. Okay. In either case, this class of structure may be termed to have single point vulnerability. Okay, maybe the bridge collapse because of the adjacent member of single loading event. Because of that, the bridge collapse. That is the reason. Okay, and then in either case, this class of structure may be termed to have single point vulnerability. Okay, conclude that it is high time that progressive collapse consideration be brought to the forefront of long span bridge design. Okay. to do what? To enhance the safety and reliability in the built environment. Okay, for safety purpose, so that it will not collapse or something else. That's all from me. Okay, for the next real engineering application. Okay, we have Pratt has diagonal intention, right? We know that Pratt has diagonal intention, vertical in compression, except for the heat. Okay. Um, Pratt were initially built as a combination of wood and iron members, but was soon constructed using only iron or using only steel. Okay, we're not going to use wood and iron members. Okay, for the major subtypes of the Pratt design, they have about uh, they have Pratt half hip truss, Whipple truss, Parker truss, Baltimore Baltimore or Petit Truss, and Pennsylvania, or we call it or as known as Petit. Okay, so for example, we also have not many bridge in wood and iron were built to this pattern. Okay, when compared to the whole truss, it was necessary to adjust two rods instead of one, and the fact that the rod ends were inclined made it more difficult to tie the nuts. Okay, so for the next one, for example, okay, in the 1850 and 1860, iron, iron members started to replace wood as the material of choice by the railroads. Okay, the first man who ever built a truss with a single tension was named by Square. Okay, by using the method of joint, all the loads in each member of the truss he built, he managed he successfully built several change bridge of the Erie Canal in the mid to late 1850s using cast iron for his compression member and wrought iron for his diagonal and lower chord. That means he managed to build the iron members of single tension diagonal. Okay, in the mid, okay, over the area canal. Okay. Supposedly the bridge was used where it was necessary. Okay. But it was replaced from was originally in Rochester to the part near Palmyra in New York. Okay, this bridge was replaced. It was replaced from the first one, from the first initial bridge that was actually built. 80s. Okay, um, the vertical wrought iron replaced people cast iron compression. Okay, the top chop vertical and diagonal were built up periodic section, which is the periodic section also the one of the types from Pratt Truss. Okay. These bridges were successfully prefabricated in shops. Okay, it was successfully okay. They become what was called by some catalog bridge, in that a local at the number of land and a bridge company would supply and frequently erect the bridge. So the government would supply and erect the bridge because of the stabilized bridge that managed to stand all the way, which had which have make the government pay attention to that bridge, which is Fionic section. Okay. Lastly, we have to span Fairground Avenue Bridge. Okay. This bridge has actually have keystone polygonal compression members connected by cast iron junction blocks and links for the main diagonal bars for the counter ties and link for the bottom chord. Okay. The two spans were originally built as a total of 8 approach spans to a bridge across the Mississippi River at Dubuque. Okay, it was designed by the Keystone Bridge Company under Jacob Hayes Linville. Okay, it's actually in these two span we have two bridge and then another two bridge. Okay, why we have like four truss of bridge? For what is for the to make it more stable, so that when people going through the bridge, it would not fall down or something. It will make it more safety like that. That's all from me. Thank you.
Calculation of external force. To calculate external force, we use formula sum of H equal to 0. Then we will get AH equal to 0. Then we will use sum of V equal to 0. Then from that we will equate AV plus BV minus 2 times 80 kilonewton minus 5 times 160 kilonewton equal to 0. And then we will get AV equal to BV equals to 480 kilonewton. That is how we get our external force. To calculate the internal force of this thread, we will start with calculating the internal force of joint A first. We will assume the angle equal to 45 degrees. Then we need to solve the vertical equilibrium using sum of V equal to 0. Then we will equate AV minus 80 kilonewton plus N7 sine 45 equals to 0. Then from that we will get N7 equals to negative 565.69 kilonewton. After that, we need to solve the horizontal equilibrium using sum of H equal to 0. From that, we will get N7 cos 45 plus N1 equal to 0. Insert the value of N7, then we will get N1 equal to 400 kilonewton. The discussion for external force. As the structure is statically determinate, the reaction forces can be calculated with the three equilibrium equation, which is using vertical equilibrium formula, which is sum of V equal to 0. Second one, using horizontal equilibrium formula, which is sum of H equal to 0. Lastly, using moment formula, which is sum of M equal to 0. In this case, we use the vertical equilibrium formula and horizontal equilibrium formula, as it was easier to find the external force using this formula. As the structure has one pin support and one roller support, the structure uses a hinge connection where the moment in the hinge connection is 0. Discussion for internal forces. To calculate the internal force in each member, we need to analyze every joint so that we can determine which joint we can start calculating first. In this case, we choose to calculate joint A first. In the calculation of internal forces in jointly, we can see that N11 equal to N12. This is because the members are symmetry with each other. That is why they have the same internal force. This condition applied to another half of the members of the structure. That is why we only calculated half of the members. The list of the symmetrical members are N1 equal to N6, N2 equal to N5, N3 equal to N4, N7 equal to N17, N8 equal to N16, N9 equal to N15, N10 equal to N14, N11 equal to N13, N18 equal to N21, and N19 equal to N20. By listing this, we succeed in calculating all the internal forces of this structure.
Lastly, its conclusion. In conclusion, the Pratt Truss design is highly efficient and widely used structural engineering solution characterized by its simplicity and effectiveness in supporting heavy loads over long spans. Its distinctive diagonal members slanting towards the center of the span provide stability and cost effectiveness, making it a popular choice for various applications such as bridge, roof, and industrial structures. The Pratt Truss balanced combination of strength, durability, and ease of construction contribution to its enduring popularity in civil engineering and infrastructure projects around the world. That's it from us. Thank you.